Good afternoon, guys. Good afternoon. Good air quality forecast. Why is all the news about Trump? So coding, ChatGPT, Gemini. Honestly, these days, ChatGPT is not the same ChatGPT it used to be. I'm kind of sorry for them. Like, I think they have models that can do better because I remember earlier version that used to give complete answers. Now they feel like they're just being economical or stingy on the tokens they generate or whatever. Maybe merit to have two users on the platform and then having too much users making it difficult, but so we wanna featureize and we wanna alright, let's see what it says. Dude, third time you are charging me. What the fuck is happening? How many times? So the other one, Gemini. And hello, Amir. I like that. They're exactly the same shit. Like their design. Now Anaconda, Jupyter Notebook. I'm so happy. I'm so happy. We have AI now. AI. I love you, AI. You are the best. AI. OneDrive. One drive. OneDrive. Thesis. So we had Expedia data, we had Cascade, we are gonna go back to Cascade. The things we wanna try today is, let's take a list, make a list. So we have two main things. One is create, not create, generalize the code for Cascade for Cascade to estimate. Is it called estimate or learn slash parameters of Cascade, which means i.e. quitting probabilities. And 2 is see how robust is the cascade to other modes of generating clicks. Like what? Like multinomial logic. Like multinomial logic, like the other one, tell me. And the other one is top K, or even a mixture of unigrams, right? Let's see how robust is it. Is it like, does it work on other methods of, or like point click, not point, it's called position bias? No. I don't remember. Alright, import a NumPy NP, simulate click data from a 2-type cascade model. From iteration tools, import chain, combination, import pandas, and do it with AI, I can do anything. Definition, no click probability 0. Single type probability of exact subset of clicks. Single type. We use it as a function for generating probability of a subset of things being clicked once we know your type. No click probability is 0 based. 0 based is like number 1, 0 or 1. Alright. Start R and Q. It can take RA or RB. Q is the exit probability. It takes probability that from position start to n minus 1 there are no clicks. There are no clicks start after. Under the cascade model, 0 based, given that the user observed position start minus. So if we observed a start minus 1, what is the probability that we have no click on a start and anything after start? So we can have a Q of a start, or we can have 1 minus Q of a start, but we should also have 1 minus R of a start times Q of a start plus 1, and goes to that, like this summation. N is len of R. If start is greater than n, what does that mean? It's 1. The probability of no click afterwards is 1. Return 1. Exactly. No position left, no chain from Q of start minus 1 plus 1 minus Q of start minus 1 times sum start and total. Partial product y minus Q of m, 1 minus R of m. And alright, 5 minutes. For J in start to n, start included, n is not included, no click, then exit at J, then exit at J, exit at the start. Exit at the start is partial product, which is 1 times Q of the start. That is the thing I don't like. There is a problem here. Then exit at Q of a start minus 1 plus 1 minus Q of a start minus 1 times total. Alright, I have a problem here. Okay. What if n and the start are equal, right? I mean, start equals n minus 1. So it's n minus 1. Probability of exit at n minus 1 should be 1. Partial product. What is the partial product? Which is 1 times Q of n minus 1, which is 1. 1 minus R of n minus 1. I don't like this term. And this is not true. Oh yeah, it is true actually. What the fuck? Yeah, of course. We don't want to have any click at start included and after. So we should have 1 minus RJ reverse. So that's true. Okay. And then we plus. And then partial product. We don't click. We keep our 1 minus QJ, we don't click, we don't exit, we don't click, and we go. Okay, this is true, this is the correct function. Alright. Probability of subset click 0 base. You are okay, click 0 base. What does this mean? Don't look at your phone. Subset click 0 based. Probability of subset click URQ, the same thing. Oh, okay. Now you say what is the probability that? Okay, that was probability of no click getting no click after start and after. Now I want to say what is the probability that a subset U gets clicked. Alright, probability that exactly and after U gets no click, right? And the subset U of position or click for a single user type with click probability R and exit probability RJQJ. Sean, U sorted equals sorted of U and N equals len of R. If len U sorted is 0, which means U is empty, it will probability of return no click probability 0 base 0 RQ. What is 0 RQ? Is Q1, right? Oh, okay, it can be just more than Q1, like it can be Q1 and then we see all the lists and get no click also. Alright, makes sense. Okay, so we need to return that function. Probability 1, previous click is -1. Position before the first click is -1. For position in usorted, from previous click +1 to position -1 to not exit, not click. Exactly. Dude, ChatGPT is crazy. I mean, we can, like, as humanity, honestly, if we don't start any war or anything, we don't get stupid crazy, we have so much room for progress. It's crazy. I hope nothing bad happens in the world. This is too good. It feels like it's just like if sometimes, like, I know, let's just stay positive and like good things happen. For pause in use or that. Generate previous clicks. Probability is 1 minus q just 1 minus rj. Then at position we must do not exit but click 1 minus q pose times r pose. If pose is less than u sorted -1, the last one, prob times probability 1. Else we are at the end, so we wanna just click on it. Why don't we have y minus cube? Why I don't get it? Oh, okay, because I included it already in the prob. Like I'm saying, next line prob is prob times no click probability, and in no click probability we already have q of a start -1 plus either we exit, which is q start -1 plus 1 minus, exactly. Return prob, that sounds correct. And then now we have like two types. No, we don't have. Then we want to talk about the expected number of clicks. Definition, compute expected number of clicks, two user types, zero based. So we have R1, relevance for type 1, relevance for type 2, is for type 1 user, type 2 user, Q area of exit probability shared by both user types. That's easier, expected number of clicks. 1 and 2, each with their own relevance, click array R1 and R2. 2 and Q all lengths and 0 base position 0 to n -1, P is probability 1, n is length of Q. Dude, it feels so good, honestly. Fucking n is length of Q, and I mean, even before AI, it was really good. Like we had YouTube, we had Google, and now it's very even better. I mean, we are becoming faster and faster in having access to data and learning. Like our learning rate will skyrocket, and the things we will know will become, I mean, the more we know, the dumber we get, but the cost of learning is decreasing, like the cognitive load part. We just get to the point faster. I hope so. It's really good, like, because I'm reading this book and every question about the definition in the book I just start asking ChatGPT. In the past, it should be like, oh, you go to the class, maybe the teacher tells you about this definition, maybe you ask the question, yes or not. You are shy, class has time limit, other people are asking question, teacher needs to teach the thing. Now you have somebody that you can ask everything. This is amazing. This is really good. Definitely, education will change for sure. Like, education becomes something crazy. Like, if we get rid of all of these bullshits, right? What is left for a teacher to teach a student? I think we need education. We will need new versions of education, or we don't need education at all. I don't know. Close that, shut that department of education. I don't know. Let's see what happens. Let's see what happens. All right. But it will be a revolution. It will be a revolution. N is ln of q. All right, and or R1 or R2. By the way, do we know R1? Do you know R2? No. So maybe we want to find R1 and R2 as well. N of R1 equals N of R2. Assert R1, R2 must be equal lengths. O.J. Simpson. Probability of reaching position J. O is NP of 1s for J. OJ is OJ minus 1. Is probability of observing 1 minus QJ minus 1. OJ minus 1. So O1 is O0. O0 is 1. Yeah. O1 is O. How does that work? Okay. Yeah. O1 will be O0, which is 1 times 1 minus Q1. Because it's alright. And P the O times R. E2 is this, and P1 1 minus P2. Perfect. Now we want to simulate the cascade model. I don't know, we checked this code multiple times, just I'm reading it again so that I get back. We deviated from this path of cascade and we came to, we did some other work like multi-touch, we multi-hop, we also had a lot of talk with like these lawyers to give us the data. Anyways, simulate cascade sessions to user type 0 based. Number of sessions, alright, we should give it exactly how many users. R1, R2, we have 2. Okay, it is also based on that if we generate. Yeah, actually we did estimate R1 and R2, but we assume that we know Q. Exit probability area of length N. P is probability of user being type 1. Okay, random seed is none. I don't know what that means exactly. Oh, if you want to repeat a simulation for the same click model, we can set the random seed and that's fine. Simulate a number of sessions under 2 days. Alright. Alright. I'm down for a band for pen. Alright. You should British. Alright. I'm just I don't know. Okay. Alright. I'm down for a band. Fuck that. Simulate, and then if random send is not none. Okay, np.random seed of random seed and len q assert like click per position, clicks per session, right? For each user we are getting his click, and for each we are also piling or stacking these click sessions. Clicked position. What is the difference of clicks per session and click position? Alright. Number of sessions, pick user type. User type is randomized less than p or greater than p. RR1 if user type 1, else R2. Session clicks equals 0. Session position clicks is null, and then we start. J less than n. If np random less than rj means we are clicking on the item, else we are not. Session click plus 1. Alright, so we are gathering two numbers: number of sessions, the clicks, and also we are gathering separately number of clicks in each session for each user. Plus 1. Session positions click dot append is j. Alright, and is less than qj means we are gonna exit break. J equals 1, otherwise we are going to the next one. Now we want to find the probability of a subset being clicked under two users. So we have a vector RA and we have a vector RB. If an item does not belong to the same category, it's, for example, if it is from category B, its RA will be very low, but still it follows the R or RA. And yeah, I mean, tomorrow I really wanna show some simulation results mostly, so let's get this stuff ready for that, and then the other part is quite easy, generating different click behavior models. So main focus, let's find let's establish that how we are gonna find, we are gonna take our coding thing one step further, and we wanna let our EM algorithm estimate exit probabilities as well, instead of it being given to it. And then we find those, then we find categories, and then we wanna also create other click sessions, but not from a cascade model. Either we can generate those clicks from different, if we are generating from different cascade model, doesn't matter because we have few. One thing we showed in the past was alright, we generate the cascaded model with one queue and then estimate those relevance vectors with different queues. And it looked like it was very robust. This time we are working in more generalized. EM will give us the queue. So we need to have click sessions provided with other click behavior, like multinomial logic. Alright. Oh. Probability of subset click to user R1, QU, R1, Q, U, R2, Q. U, R1, R2, Q, and P. this subset. Alright. Okay, alright. And then demonstration. Let's give it 5 minutes. It's really good. Dude, like AI is a true assistant. That's what it is. It's a great assistant. Amazing. Demonstration. We can just talk about ideas and AI can make it precise in a sense, like this cascade model code. Or we can talk about intuitions and conjectures and fucking AI make it rigorous. Oh, this is amazing! It is such a big freedom, like getting rid of all those logic. Like at the good spot, like logic, when is logic bad? When you want to have an idea but you need to make it rigorous. But alright, once you establish your thought, you want to make it rigorous to make sure that everything is fine. This vibe coding thing is amazing. Alright, so I have to take a break. Do I need to? Yeah. So, alright, now we just run this code, demonstration, name equal name main. Example is n equal 5. N is 5 is just bullshit. Type 1 user, I think we don't have n equal 5. R1, yeah. Okay. Type 1 user has click probability. R1, type 2 has R2, R1 is this number, R2, and we are in the example, we are just setting R1 and R2 based on 0.1 or 0.9. Right, I mean, it's totally relevant if 0.9, not relevant 0.1, and Q is like constant 0.2. 70% of our type 1s and 70% type 2, and this is expected number of clicks. E compute expect R1, R2, R10, simulation, like we have 100,000, 10,000, 10,000, 10,000 clicks, position click, simulate cascade session 2 user types. So we generate those clicks, print f simulate number of sessions, clicks per user, and then also print simulated. So here we are saying there is no bias from relevance of the items. All the items in one group have same value. And then we are saying probably that exact subset U is example 03.1. And then we are getting the probability of a subset within click. This is not necessary. So I'm gonna delete this part and do we want to run this code? No. Let's go further. Positions clicked, and then we have them, and then this part, which is the estimation section, estimate category specific relevance EM. This part just assumes, just finds our A estimate and our B estimate. We wanna make it stronger. Let us find Q as well. We know that it is kind of robust to Q. So one thing we want to may suggest is that this shed is robust to Q. Do I have it already? I think I just tagged it out. When I'm here. So I think I just commented it out. Not this one, no. Where is the part we have all the, no, not this. Okay. The sections, and then we have sections. There's no sections. All the stuff, proposal, decision. Flooding university. What does that mean? So where are the floods? I think I have them in a PowerPoint, right? Exactly. Floods. Not this one. Maybe this one. So, for example, I have this. This is all good, but I want to know what are the Q and R. Where did I store them? Wait a second. What are we doing? I thought I have this. I just want to know. I didn't plot them. Okay. So I think we're gonna plot more, and then Yeah, just okay. For tomorrow, let's show people what we have, what we think, so that go on the same page with us. Yeah, tomorrow just because I think we did a lot of simulations, but we didn't publish it for them, so they don't know what we did. They don't have any idea. And tomorrow we can just describe what happened, and that's fantastic. Um, Category specific revenue, relevance. Log likelihood mixture click RARBQP computes the total log likelihood for the mixture model. I input P log n of P PUIRA on PUIRB L1 equals 0. What is L1? Is it LL or L1? For you in click list, PA is probability of subset. Alright, let's look at the main code first. Alright, example usage if name equals main. Suppose we have n equal 9 items. The exit probabilities. We don't want to assume we have the exit probability anymore. P is user type A with probability P. So alright, one thing I want to show, things to show. So we had some things to do and we want to have some things to show, some stuff to show. Things to show. What is this email? Just make sure. So we don't take any homework, but we want to make sure they know where we are. Alright, perfect. So one thing we want to show robustness of Cascade to Q. Alright. And then I want to imply that, alright, finding Q is not that important. Yeah, let's do that. Alright. Alright, so and then we do estimation. NumPy as NP and is 9, Q is this. It's a completely different Q, it's 0.95, it used to be 0.2. P is also P as well. P. Click list, position clicked, run mixture based cascade, EM, no ES step, just so it's not important, practical point of view, which is everything. But we need to show them. I agree with this part. It is not fair if we just tell them without showing them. I agree. Click list positions, click, run mixture array, alright. And then we have, alright, then we said, alright, we can have this EM model, and the thing with EM was not, we were not happy with, which was like, it takes long time. So 2, we want to tell them EM takes time. That was the reason we moved to LDA. Now fuck LDA, MU, mixture of unigram. So I want to write down all of this stuff too, so that they know. Why do we normalize like that, by the way? We don't need to normalize. Alright, I mean, just saying this stuff is enough. It is too many works to be done. Okay, we are timing it as well. Don't print. And then we should have a part that we are plotting all of them. Yeah, and we want to have them in overleaf so we don't get back to these simulations again and again. However, I let um, did I not write anywhere? I feel I wrote down. Let me check. Yeah, simulation the text. Yeah, we had the simulation part. Yeah, we just Categories, featureization. Oh, okay, I need to put sections, alright. Every time you have this with log likelihood. Which one is log likelihood? So log of probability of. Yeah, why do you put fucking. Every time you put it wrong. This part, this. See, that's the part that we are as good as a PhD student doesn't work. You have like a stupid problems, ChatGPT. Don't be arrogant. You still need me. Fucking dumb AI. Every time. It's just a problem it has all the time, by the way. I'm correct. Oh, I'm not correct. Dude, this is a stupid. Let me show you. So it says your version with the tick, check mark, and green, and it says this is not the correct MSDiv objective. And then my previous version, which is as like cross, says is correct for MSDiv of EM, not what you wrote. Let me self-responsibilities. Oh, okay, so you are. So can you educate me? Exactly. Alright, then the likelihood of data, we agree on this. Log, exactly. So this is P is inside the log. I like that. Why doesn't EM maximize that degree? Okay, that's about EM. So I am right on a theoretical level, I guess, but EM does not do that. EM instead says P log of this motherfucker and plus 1 minus P log of that is a log of a sum, which makes it hard to optimize directly. It covers. So is it the estimation step we are taking? Yield trackable. So EM introduces a trick. Oh. Define latent variable Zi in A and B. Instead of maximizing the observed data, EM maximizes the expected complete data log. Mm-hmm. EM is the objective. Yeah, okay. Yeah, okay. So this is a lower bound, and since we are maximizing, we want to maximize the log likelihood, we can maximize the lower bound. Alright. The EM and also behavioral evaluation like inference. I see. I see. Okay. So why do we try to maximize the original? Maybe. That shows you're really thinking like a researcher. So how trackable? I don't know how trackable the other one is. Also non-convex. Alright. If you are okay with this. But the current EM was already slow enough. EM is faster, more stable, and separate optimization. What is the so take a look at my previous sections. What about the simulation? Why didn't you show it? You mean you don't show after this? What the fuck? Where is it? Alright, I just want to see simulation, to be honest. No, by the way, MML what about MMNL? So we have up to LDA. I want to see what's happening here. Who writes this? Where is it? Yeah, we don't want this. These are bullshit. Alright, MMNL for now we can tag it out. Hierarchical, I think we are good with hierarchical. What the fuck? What's wrong? So we have a lot of plots to show actually. Right. Alright, I need to go to the restroom. Alright. So simulation. And then what do we have? After simulation, yeah. Visualization. Okay, so these stats are important. We already have. So we have a lot of actually plots. Which is great. I don't need to plot them again. Let's get the code. This is these are done already. This is type, cell type. So these are all this Oh, okay, minimize it as these are extra repeated. Oh, LL is log likelihood. Alright. So oh shit. Why is P params 1 minus 1? Is it like 1 variable? Oh, at last I see. Okay, makes sense. But we didn't define. Where is the param? Ah, okay. Alright, sounds good. Because we don't want to divide by 0. Just to make sure that it is not 0 minus sounds good. That's it. That was so simple. Okay. I think we can just remove this part. Because we're gonna make. Initial point concatenate 0.5 for everybody, and then also for Q and also for everything. Alright, downs. Alright, yeah, for relevance, for exit probability. Not really. For the last one, what about the last one? Okay, fuck it, let's have it. LGBFS method, I would say method. Sounds good to me. Dude, it became so fucking easy. That's stupid. How many? How many? Maybe it's a big number. Yeah, that was not a good idea. Number of sessions. Yeah, this is the part, right? Yeah, 10,000 is too much. 200 click session takes 90 seconds. I mean, EM, not the fucking thing. Alright. Let's make it 100. Because mixture of unigram is quite fast. So we need to have these plots actually. So that we show that why we want to use mixture of unigram. You know, what are the advantages? Tomorrow we want to show, alright, this is the graph, and this is guys, I don't know why, but I feel I need to go to the restroom again. So 53 seconds. Maybe we can plug them with that. What is the simulate click function? Yeah, that's bullshit. Actually, I want to have for that. Click list. What is the name here? Positions clicked. What was the real number? 0.9, right? 0.9. Where is it? Fucking, I'm losing my head to be honest. 0.9, but it's like 0.75. It's very. That's actually terrible. This is interesting, let's be honest. It shows, like, we can see how EM does better. So okay, let's go to ChatGPT. So these two gone. No fucking way.